Next thing I'm going to hand out here is some extra practice from what we did last time on exponents. This is also on Moodle with the answers. Basically, just to give you a little bit more practice with exponent stuff. And we're going to do more with exponents as well as we go along. Today, we're just going to introduce some other types of exponents that will be fractions rather than whole numbers. So let's just do a couple of these to start with, make sure that we're remembering all our exponent rules before we talk about rational exponents today, and then we will do your quiz at the end as usual. So I'll just pick a couple out here. Let's look at this number 3 that's off to the side on that sheet I just handed out. So in number 3 here, we've got two expressions being multiplied together. So I would always handle the numbers and then handle the variables. That's just my way of doing it, making sure that I'm keeping things straight. So if I handle the numbers, what would you do with the 2 and the 5? Just multiply them, right? So you'll end up with a 10. Okay. What about for your x's? Again, we're multiplying here. When you multiply, what do you do with the exponents? Add them, right? So we'll get x to what power when you add those two together? So you get the -4 plus -3 gives you -7. And what do you get for the power on the y then? 5? Because you'll do -2 plus 7. Okay. Yeah? Is that okay so far? Now notice the problem also asks you to write your final answers with only positive exponents. Well, we've got a -7 there on the x for the exponent, so what do you do with it? Yeah, put it over the denominator, right? So their final answer here would be 10y to the 5th over x to the 7th. Does that make sense? Let's do just a couple more, and then we'll get into the rational exponents. I want to leave, like I said, I want to leave plenty of these for you for practice, especially since we've got a long break between now and next Monday. You might want to look at a few of these before then. But let's look at number 4 here. What do you want to take care of first? You got a couple of ways that you can go with this. But what do you want to take care of first? The numbers? Okay, sure. Let's do that first. So we do the 12 over the 4. That gives you 12 divided by the 4 gives you 3. Good. I'm going to leave this. Well, we'll do the squared second here. Let's keep working on the inside. Now we've got x to the 9th over x to the 5th, or x to the 9th divided by x to the 5th. What do you do with the exponents in that case? Subtract them, and we'll get x to the 4th. So we'll simplify it inside the parentheses there. What can I do with this 2 now? You can distribute it to both pieces, right? You can do 3 squared, and I'll write it out longhand here. We can distribute it to each piece since it's multiplication. So we have 3 squared times x to the 4th squared. Let's simplify the number again. 3 squared is the same thing as 3 times 3 is 9. Good. And then what do you do with the exponents when you've got x to the 4th raised to the 2nd? You get an 8, right? You multiply them, right? So 4 times 2 will give you the 8. All right? And we're going to practice more of these rules as we go along with today's lesson as well. But this okay so far? Okay. Let's just do one more. Let's do this number 5, and then we'll start new stuff. Again, by the way, I said there was a couple of ways you could have started this problem. You could have first, if you wanted to, decided to take that squared and distribute it everywhere first and then simplify. That would have been okay too. Either way would have worked. You would get to the same place. What do you want to do first here in number 5? Yeah, I'd probably do I would just distribute it, right? Do that first, get that taken care of. So I could write that as 4 to the negative 3. What am I going to do with this exponent when I take the negative 3 and distribute it here? What are you going to do with those exponents? Multiply them. So you'll get x to the 9th. And then again, when I distribute it here, we'll get y to the negative 15th. Because we'll multiply again. And now we want to take care of the negatives. So again, this is 4 to the negative 3. So where do we put it? In the denominator. And we have y to the negative 15. So we'll also put it to the denominator. But the x to the 9th stays on top. So again, when you have a negative exponent, you just basically switch its position, right? If it's on top, flip it to the bottom. If it's on bottom, flip it to the top. Okay? Last thing we'll do is simplify the number. When you do 4 to the 3rd power, what do you end up getting? 64? Good. So you'll have x to the 9th over 64, y to the 15th. Any questions on that one at all? Right. So again, like I said, I'm going to leave those for you for practice. We're going to end up practicing more problems like this here in a minute when we deal with our stuff here with rational exponents. So let's start that off today. All right. Pardon me. Okay, here we go. All right, so when we've talked about doing things with radicals, with square roots and cube roots, and of course you have fourth roots and fifth roots and so on. Sometimes it's convenient to write those radicals as an exponent. So when we have something like cube root of x, we can convert that over to an x to the 1/3 power. In general, whatever you see in the denominator is what root you're taking. Okay, that's what that means, right? So, pardon me. So again, it's the same kind of notation that we had last time. The expression that we have here is called a radical, just like it is before any other time. Yeah, we've already mentioned that before. Or, in this case, we might also say an nth root. We might call it a root as well. The symbol itself, just like before, it's called a radical sign. The n, that little n there, we refer to that as the index. And the a is the same name that we gave it before. That's still the radicand. So the only real thing that we're doing different today is that we're using a fractional exponent to describe what root we are taking, what the index of the root is. So when we look at this first example, we have 49 to the 1/2 power. This is telling you, right here, this is telling you what root to take. So if it's a 2, that's telling you to take the square root. Okay. We could put the 2 in as the index, but remember we talked about that before. If you don't have an index there, you just assume it's the square root. And then what's square root of 49? 7. Good. So 16 to the 1/4 power means what root are you taking? 4th root? Yep. And so I need something that when you raise it to the 4th power, you get 16. 2. Good. Or if you need to, you could use your factor trees again. We've talked about doing that, right? Just to remind. 16 is 4 times 4, and each of the 4s would split up as 2s. And since you're doing a 4th root, you're looking for a group of 4. If you need to do it that way, that's okay too. What about the last one here? What root are you taking? Cube root? And what is cube root of negative 27 going to be? Negative 3. Good. Remember when you do a cube root of a negative, it stays negative. And then cube root of 27 is 3. Because 3 times 3 times 3 will give you 27. So far, so good? Okay. All right. So, pardon me. When we have an actual honest-to-goodness fraction with a different numerator than just a 1, this is telling you what power we have. So notice that in your notes, it notices that, remember when we have our law of exponents, we can multiply in these situations? So I can think of this either as 1 over n raised to the m power, or I could do my power and then do my root. Okay. So either way is acceptable. When you have m over n, I could write it as do the root and then the power, or I could do it as the power and then the root. Either way works. That's all that's saying. Okay. The top tells you what power to take. The bottom tells you what root to take. Okay. Now, what I would suggest doing personally is do the root and then the power. Only because if you're actually doing a computation, I would do the root first and then the power. Because it gets it smaller. It's easier to recognize what the roots are for smaller numbers than bigger ones. Right? If I do the power first, then I get a really big number. I may not recognize the root. Is all I'm saying with that. All right. But in general, you can write it either way. So again, what power are you taking with this first one? What power is it? Which will you look at for the power, the top or the bottom? Top. So the power is 2. The root is 5. Good. So again, you could write it either way. You could write this as the 5th root of x squared, or the 5th root of x squared. Either way works. Either way is perfectly acceptable to write it. Again, the top tells you what power to take. The bottom tells you what root to take. Now, when you're writing it with variables, usually you'll see it written in the first way because you don't have the parentheses there. Makes it look a little bit nicer. Okay, so then for the second one here, first off, does this power right here apply to the 3? Is that on the 3 or just the x? Just the x, right? So when we rewrite this, we don't want to rewrite the 3 under the radical at all. The 3 is all by itself. Okay? How do we rewrite the second piece? It was hotter than heck in my last class. If I open the window, I'll just shut it most of the way here. How do we rewrite x to the 4/7? Yes.
Would it be like the radical, and then it would be x to the 4th, and then it'd be to the 7th?
Okay, so the x to the 4th is under the radical, and then the 7 is the root, right? So it's the 7th root here. Yeah. Yep. Yep, that's exactly right. So again, the denominator is telling you the root, the numerator is telling you the power. Let's look at the third one here. I would simplify this with the fractions first before writing it with radicals. Notice I've got multiplication. What is when you multiply again, what do you do with the exponents? Add them, right? So we can first just add those exponents together. So I'd have x to the 1/3 plus 1/2. I need to add those fractions together. I need to get a common denominator, right? Let's do that off to the side here. I want to do 1/3 plus 1/2. What would your common denominator be? 6. So the first one is 2/6. The second one is 3/6. So we'd have 5/6, right? And so how would you rewrite that now using radicals?
Power of 5.
Say it again.
Power of 5.
Yep, power of 5. Good. Yep, 6, yeah, so the 6th root, exactly. So it's the 6th root of x to the 5th. Yep. So again, x to the 5th is just x to the 5th, right? That's the power. And then we have the 6th root is what that's telling us to do. Notice that that's a lot easier to simplify this way as a single radical. If you would have converted this to radicals to start with, you would have that, wouldn't you? X to the 1/3 is cube root of x. X to the 1/2 is square root of x. Is it obvious that this simplifies to that? Looking at it that way? Not really, right? So it's a lot easier to simplify your exponents first and then rewrite it. Okay. So that's why we're playing around with these things. Okay. Let's do a couple of these down here on the back side. And again, these are going to be using your properties of exponents is the whole point in playing around with the radicals. We're going to leave our things here with exponents in them. So we're not going to worry about rewriting it in radical notation for this to start with. Pardon me. So again here, what can I do with this exponent here with this product? We can distribute it, right? So this is x to the 6th to the 2/3 times y to the 5th to the 2/3. That's just taking it and distributing it to each piece, right, of the product. What do you do with your exponents now in that situation? You multiply them, right? So when we do 6 times 2/3, Well, the 3 would cancel into the 6 2 times, so you would get x to the 4th. Not a lot of canceling we can do with this one. We just have y to the 10 over 3. And this one's not asking you to rewrite it in radical notation. This is just leave it. That okay? Yes. So 6 times 2/3, that's 6 over 1, right? 3, 2. Yep. Yep. Let's look at the second one here. Is there much simplifying we can do? Inside the parentheses, is there much simplifying we can do? I don't think 8 and 27 have anything in common, do they? No. And then an x and a y. So really all we can do here is distribute our exponent again, right? So we'd have negative 8 to the 2/3 x cubed to the 2/3 27 to the 2/3 y to the 4th to the 2/3. All right, that's just literally just distributing it. Agreed? What do you get? Let's look at the variables first, and then I'll play with the numbers. Well, what do you get when I take x to the 3rd and raise it to the 2/3 power? What do you do with the exponents again? Multiply them, right? When I take 3 and multiply it by 2/3, what do you get? You get 2, right? Because your 3's will cancel. So I'll get x squared, right? For sure. On top, or excuse me, on bottom, when you do 4 times 2/3, there's not a lot of simplifying, is there? So what will we get when we multiply those? 8 over 3, good. I still have to deal with the numbers, but are we okay with the variables? Variables okay? Yeah? Okay. Let's worry about the numbers now. Pardon me. Again, I'll write it out here for us, but I'm going to just write our final answer here. The bottom tells you what root to take. The numerator tells you what power to take, right? When you're simplifying it with numbers, I would always do the root first and then the power, okay? When you're simplifying it with numbers, I'd always do the root first and then the power. So this says to take the cube root of negative 8 and then square it. That's what that says to do, right? The 3 tells you to take the cube root. The 2 tells you to square it. What is the cube root of negative 8? Negative 2. And then squared, we get 4. So this will be a 4 on top. What about 27 to the 2/3? What do you get for that? Very good. That's exactly right. So your 27 to the 2/3. Again, the 3 tells you to take the cube root, and the 2 tells you to square it. Do the cube root and then square. Cube root of 27 is 3. Square it, you get 9. Your calculators will do fractional exponents as well. But make sure that if you type this into your calculator, you use your parentheses appropriately. If your calculator doesn't automatically put it up as an exponent. What I mean by that is, if I want to do that 8 to the 2/3 or negative 8 to the 2/3, make sure you put the 2/3 in parentheses like that for your exponent. If you don't put the parentheses, it'll square it and then divide it by 3. Divide the answer by 3 instead of putting the 3 in the divided by 3 in the exponent. So make sure you use your parentheses appropriately. Let's look at number 4 here, and then I'll get you started on your quiz, and I'll leave the other practice sheet for you for over break, and then we'll do a couple of those problems when we get back. This one's a little different, right? It has radicals to start with, doesn't it? And it's asking you to simplify. All right. What I would do first, and what you should do first to simplify this, is rewrite these radicals as powers. Notice that 4th root is way on the outside, right? How do you convert a 4th root into a power? What do we write for the power if it's a 4th root? 1/4, good. The next one, we have a 5th root. The next thing that's on the inside, right? We have a 5th root. How do we write it as a power? A 5th, good. So I've got the 5th root of this and then a 4th root of that whole thing. You see it? Okay. Now, why did I write it this way? What can you do with the exponents? Multiply, right? When you multiply 1/5 and 1/4, what do you get? And so 1/5 times 1/4 is how do you multiply fractions? Yeah, it's just 1/20, right? Multiply across the top, multiply across the bottom, right? Get 1/20. And now what can we do with this exponent? Distribute. So we get x cubed to the 1/20, y squared to the 1/20. And then finally, what do we do with the exponents in that situation? Multiply them again, right? So we have 3 times 1/20. And if you need to use your calculators, please do. Your calculators will do fraction stuff. If you need help with doing fractions with your calculator, come see me. I can show you how to do it. This is the same thing as 3/1. So what do we get when we multiply those together? 3/20. And the other one will be 1/10. Good. And it's 1/10 because you'll have 2/1 times 1/20. And the 2 goes into the 20 10 times. What questions do you have? Right. So you got a whole sheet of practice of these. Answers are on Moodle with those as well. I would encourage you to practice these over break. Or at least practice it on Sunday when you get back from break. Right. We'll do some more examples of these next time, as well as to get into some new stuff. I know it can be confusing, that's why you want to make sure you practice them. There's only the front side of the quiz. There's just 3 problems on here.